Hello, my name is Joy Vincent, and I will be discussing sensory modality bias in three-banded armadillos. This small burrowing animal is one of over 20 different armadillo species found throughout the Americas. Despite the variety of species and relative abundance both in the wild and in captivity, there's still much that we do not know about armadillos, particularly with regards to their cognition and behavior. The majority of what we know about their behavior comes from field studies and epidemiology studies on leprosy, as armadillos are carriers for the disease. From these studies, it is widely believed that armadillos have a strong sense of smell, which serves to compensate for their poor visual system. In the 1980s, a group of researchers provided us with some studies that systematically investigated their spatial memory and navigation strategies. They were able to show that hairy armadillos could successfully locate food in a Y maze and subsequently learn to return to the start box. They also found that armadillos were most likely to demonstrate position habit, meaning they would continue going to the same location over consecutive trials. But the results were not entirely conclusive, as the armadillos also demonstrated other strategies. In a more recent study, Ober and colleagues found that 9-banded armadillos showed a preference for scented soils over non-scented soils, also showing a preference for the scents of closely related individuals over those of less related individuals. Given what we have learned from these limited studies, we set out to determine whether scent or location was more salient to 3-banded armadillos. Last year, I presented my preliminary data from the training phase of this study. 2 of the 4 subjects demonstrated an ability to discriminate between 2 options based on a combination of scent and location. Unfortunately, the COVID lockdowns left me without an answer to my central question. But following lockdowns, I was able to restart my data collection in order to discern which cue was more salient to the armadillos, scent or location. In this study, I worked with 4 different individuals at a facility located in Ann Arbor, 3 of which were females and 1 was a male. Over the course of this study, each individual was presented with 2 compound stimuli composed of 1 location cue, either left or right, and 1 scent cue, either jasmine or pine, with the same one always being baited for that individual. We ran this study in their home enclosures, and the compound stimuli were marked by a metal hut. Each hut had a scent board above the opening, and this is where a piece of filter paper with the corresponding essential oil was placed. Inside each hut was a bowl with a false bottom, so the armadillos would not be cued by the scent of the reward. At the start of each session, the armadillos would get access to the 2 huts and would make their decision. Once they chose, the non-chosen hut was blocked off. So in this video, you can see that the armadillo did choose the baited hut, and the unbaited hut was then blocked off. This allowed them to get access to the reward. Each of the armadillos was able to hit criteria, which was set at 80% or 4 correct decisions out of 5 trials for 5 consecutive sessions. Once they accomplished this, they were able to move on to the testing phase. In addition to their improved accuracy over the course of the training phase, evidence for their learning can be seen in their latency measures. We looked at 2 behaviors, decision and choice. The point of decision was defined as when they committed to the side that they eventually chose. The decreased latency to make a decision suggests that they were gaining more confidence in their choice over subsequent sessions. Choice, on the other hand, was defined as the time when they actually entered the hut. These 2 measures were correlated with each other, as the faster they made their decision, the more quickly they entered their chosen hut. In these charts, you can see how over the course of the training sessions, both average choice and decision latency decreased and then remained relatively low throughout the testing phase. This suggests that by the time they entered the testing phase, they had learned the discrimination and continued to maintain it throughout the testing. The testing phase was conducted almost identically to the training phase, with one notable difference. 2 of the 5 trials in each test session were testing trials, which means that the compound stimuli were put in conflict with each other. The S+ scent was paired with the S- location, and vice versa. It was the behavior in these trials that would tell us which of the 2 cues was more salient to the subject. So in this video, you can see that the subject chose the S+ location that was paired with the S- scent. The results were overwhelmingly in favor of location, as you saw in that video. On nearly 100% of the test trials, the subjects continued going to the same location, except for one trial with fire, wherein she changed location. From these results, it is very evident that the armadillos attended more to the location cue rather than the scent cue. But a lingering question still remains. Did the armadillos actually encode any information about the scent cue, or was it entirely overshadowed by the location cue? In a follow-up study, we intend to present the armadillos with a variety of scents and observe whether they show an immediate preference for their S+ scent. We also plan to investigate whether, in the absence of location cues, can armadillos discriminate on scent alone. Additionally, given their impressive performance with learning the location cue, we intend to explore what cues they are using for navigation. There are so many species of armadillos, and they all lead drastically different lives based on their size, diet, and range. This makes them such an incredibly interesting subject for comparative studies. We will be conducting this study with a hairy armadillo and hope to complete this and similar studies with other armadillo species to better determine whether this modality bias is unique to one species or generalizable to all armadillos. Given their prevalence in captive facilities and their widespread use in education departments across the country, armadillos are prime candidates for future cognitive research. With that, I would like to thank all the members of my lab, as well as Shruti and the rest of the staff at the Creature Conservancy. If you have any questions, please feel free to shoot me an email at the link provided. Thank you so much.